Redox is a reaction that is gotten, as in this is a short form, red, for reduction. Ox for oxidation.
So there are 5 ways in which we can define redox reaction. First way, I can use a table so you can understand this one. 1, 2, 3, 4, 5. And there's 6. So understand addition of oxygen. If you understand what this is, I'm going to bring out examples for each of them. So major things you're going to have in mind here is that you have to pay attention. If you don't understand this particular topic, you may struggle in the electrolysis. Not that you may struggle, you will struggle. Now, let's do the first one. We will have 2 elements. We will use an example for each of them. We will have magnesium oxide reacting with something like sodium. And here we now have something like sodium oxide plus magnesium. Now, let's use this to illustrate what we have here. Addition of oxygen. Addition of oxygen. Up here we have what we call oxidation, and here we have what we call reduction. Addition of oxygen is oxidation. Addition of oxygen is what? Oxidation. Removal of oxygen will now be what? Reduction. I don't know if I'm making sense to you. If you add oxygen, you get oxidation. You will not get what? Reduction. So addition of oxygen is what? Oxidation. Now, but if you remove oxygen, you will not get what? Reduction. Now let's talk about, let's use this thing here. If you look at this sentence now, you can see that sodium here was not carrying oxygen. But reaching here, sodium is now carrying what? Oxygen. You understand that now? Here, sodium was not carrying oxygen, but here, sodium is not carrying oxygen. So what happened here to here is what we call what? Oxidation. What happened here to here is what we call what? Oxidation. But if you look at this side, magnesium was one carrying oxygen, but reaching here, magnesium is not carrying what? Oxygen. Here, what we call this is a what? A reduction reaction. A reduction what? Reaction. Why what happened here to here is what? Oxidation reaction. What happened here is what? Reduction reaction. For here now, we can put up one thing. There's nothing I told you the last time. I said that any element, I explain what agent is for you. Yes. I said agent is something or a substance that causes something to do what happens. And I major things that the main agent most of you know is agent of darkness and house agents. The agent of darkness, you know how many attributes? The agent of darkness can cause disease, right? The agent of darkness can cause death. That's the agent of darkness. Now, the agent of a house can cause you to find your house quicker, it's not true. Now, let's talk about agents in reduction and oxidation. Anything that causes oxidation reaction is called a reducing agent. So for here now, what caused oxidation was sodium, right? So it was a what? A reducing agent. It was this particular sodium that made magnesium to be reduced. Without sodium, this magnesium could have been alone. It shouldn't have even been reduced at all. Magnesium oxide should have been going where it is going, it's not true. But here, you see that when magnesium reached here, magnesium has been reduced. Because it has been reduced by who? Sodium. Sodium is now a who? Reducing agent. So that means anywhere sodium is, it is there to now what? Reduce. Do we get that now? Now, coming to this particular phase now, anything that causes reduction is now who? Oxidizing agent. Anything that causes reduction is now what? Oxidizing agent. Because this magnesium was one that allowed oxidation to happen. Without magnesium, this oxidation would not have happened. It was not in his, it is the one, not he, because he may not be a god. So it is the one that allowed oxygen, so it allows sodium to now collect oxygen. If magnesium did not lose guard, will you see sodium collecting oxygen? No. Because of that, this magnesium is a what? An oxidizing agent. Am I making sense?
Yes.
Do you understand this now? Yes. Let's go around again. We say addition of oxygen is oxidation, while removal of oxygen is what? Reduction. Now, let's go to addition of hydrogen. Addition of hydrogen is reduction. Whenever you add hydrogen, it will now come to reduction. Now, but if you remove hydrogen, oxidation. Addition of hydrogen is who? Reduction. Removal of hydrogen is what? Oxidation. You can be writing it somewhere so that you can get across that. Now let me use example again. Are you tired of example? We will have hydrogen sulfide reacting with maybe beryllium. Now, we are now seeing something like beryllium sulfide plus hydrogen. Like this. If you look at beryllium here, so if you look at sulfur here, sulfur at this particular point was carrying hydrogen, not true. But here, sulfur is no more carrying who? Hydrogen. Sulfur was carrying hydrogen here. Reaching here, sulfur is no more carrying who? Hydrogen. Which type of reaction happened here?
Oxidation.
Which type of reaction that happened here?
Oxidation.
Because there was a removal of who?
Hydrogen.
There's a removal of hydrogen. Because of the removal of hydrogen, what's happening here is what we call what? Oxidation, right? Now, where did the reduction happen? Yes, reduction happened at where? Hydrogen. Now, oxidation happened here. Now, coming to this now, what is your reducing agent? What is your oxidizing agent? Hydrogen. Do you understand that? Whenever you see this particular thing, so here now, hydrogen has been removed. Because it has been removed when it comes here. We now call it what? Oxidation what? Reaction. Do you get that? So that's oxidation what? Reaction. Let's go to the next one. Addition of electropositive elements. Whenever you talk about electropositive elements refer to what? Melters. And I said that the most electropositive element in chemistry is what? Francu. Now, when you add electropositive elements, the same thing that happens in hydrogen will happen here. Whenever I add electropositive elements, it is what? It's reduction. Whenever I add electropositive elements, it's reduction. When you remove electropositive elements, it's what? Thank you. Now, if you have something like this, sodium sulfide reacting with chlorine. Now, you now see something like sodium fluoride plus sulfur. Plus sulfur. Having this, we have something like this. Now, what really happened here is that we say addition of electropositive elements which are melters. If you add melters, they are going to be what? Reduction. But if you now remove melters, it's going to now be what? Thank you. Now, having this now, we can start. In sodium sulfide coming to this side, sodium sulfide was, sodium is a melter, sulfur is a what? Non-melter, right?
Yes.
So coming from here to here, okay, sorry, this is from here to here, it's not true.
Yeah.
Fluorine here was not carrying anything, it's not true.
Yes.
But reaching here, fluorine is now carrying what? Electropositive element. What happened here? Reduction. Reduction has happened here. Why? Because fluorine at this particular point in time was not carrying any melter. But when it reaches here, fluorine is not carrying who? Melter. Because it's carrying melter, that is what? Reduction. Now, sodium sulfide coming to this particular point here, you can see that the sodium has been removed, right?
Yes.
You're only seeing who? Sulfur. Because the sodium, which is the electropositive element, which is a melter, has been removed. Coming to this particular place, what takes place? Oxidation reaction. Removal is now what? Oxidation reaction. Should I be using, let me use something like this. Addition. Is it better?
Yes.
Is it better than do than half?
No.
No, this is better. Addition, oxidation, removal, reduction. Removal, oxidation, addition, reduction. Better bath? Okay, anyone? Okay. So what happened here when we reached here and we remove sodium is what we call what? Oxidation. So removal of this is now oxidation. So now the agent that causes reduction is now who? Oxidizing agent. The agent that causes oxidation is now who? Let me give you a small password. Right now. Move on. Enter move now. What happened here? What happened here? Reduction happened here. I not seen it. So what happened here? Why? Reduction happened here because there was a removal of oxygen from here to here. So from here to here there was addition of oxygen. Because of that, we can fall here was
Oxidation and reducing.
and reducing agent is found here, it's not true.
Yes.
Why oxidizing agent is found? Now coming to this now, this is about the electropositive element, it's not true. So coming to this now, from here to here, what happened? Because there was a removal of what electropositive element and the resisting agent is found here. Coming to here now, what's happening here? Anybody that is confused? If you're confused, raise up your hand, let's see. Okay. So where hey, can you keep quiet so we can know the people that is asking questions? Yes.
Number two.
Second one.
Yes.
The second one is that the addition of electropositive elements. Whenever you add electropositive elements, it's always reduction from what we saw here. Addition of electropositive elements is reduction. So we added electropositive elements, it turns to reduction. Now, if we remove electropositive elements, it turns to what? Oxidation, which you saw here. So we remove electropositive element, look at the electropositive element is melted. From here, it turns to what? Oxidation. That's about that. So let's carry on. Now, addition of electronegative elements is addition is oxidation. Removal is reduction. Electronegative elements is something like oxygen, something like chlorine, something like what? Fluorine, something like nitrogen. All those non-melters, if you add them to any element, you know that what is happening here is what? Oxidation. Do you understand now? So we have actually used this one for example. So we use this one for example. Whenever you add something like oxygen, because they are what? The electronegative element is what? Is oxidation. Whenever you remove them, it's now what? Reduction. Do you get that now? Sometimes it's speed up. That's how I've not done for example.